I forgot to unmute myself. Sorry, folks. Let's start over. Hi, welcome back. Hope everybody's having a wonderful day. And yeah, let's talk about the Caesar Cipher project. If you're tuning in for the first time, hi, my name's Ramon. We're doing a free JavaScript bootcamp where we're doing the lessons from free code camp. We're doing the certification for JavaScript. If you're interested in signing up, yeah, sorry, I was muted before. If you're interested in signing up, totally check out the Class Central website. We're doing it there. You can enroll there and check out the course and catch up. All of the video recordings are there online. And yeah, so we're going to be continuing with the bootcamp today. Yeah. Ooh, and hello, everybody. Folks coming in from around the world. As always, I love to see it. People from the Philippines, Taiwan. Hello. Yeah, great. Yes. Hey, hey. Good. I love to start recognizing names of folks that are tuning in as well, but always lovely to see new folks tune in as well. And yeah, so let's first. I'm happy to be here too. From Lagos. Hey. Good to see you. Cool. Yeah. So today we're going to be doing our third project of the JavaScript certification. Just to catch everybody up, if we complete these five projects here, then we can get our certification, our degree, our certificate from Free Code Camp and that'll earn us our certificate, and then we can show the world that we can do JavaScript. How cool is that? Yeah. So just to catch us up on what we were doing so far, yesterday we did the basic data structures section. Your homework was to complete the last exercise. No worries if you haven't. What we're going to be doing today, as said, is the third project. So let's dive right in. The Caesar Cipher. So we've already done the palindrome checker and the Roman numeral converter. Now, if you haven't done those yet, again, don't stress. This is meant to be done at your own pace. I highly recommend going on the forum, going on the Discord, and checking out the solutions from folks. If you need them, you can discuss them with your peers. We're here to help each other. We're here to learn together. Yeah. Hi from Chile. Hey, hey, a fellow Chilean. Lovely to see. So, got a favor from Drew asking, please go slower than the last project. You got it. I'll demonstrate my thought process and we'll go through this step by step. Thank you for the feedback. Now, what was I going to say? Yes, we're going to be, as I said, the recordings are up on YouTube, so you can check them out at any time. And let's go into the Caesar Cipher project. I'm going to link that in just a second into the chat. Hi from Buenos Aires. Hi, Brian. Good to see you. Yeah. So sending that in. Cool. So in the chat, I've put the exercise that we're going to be doing, which is the Caesar Cipher. So first of all, we're going to be reading the exercise. Next, I will show two solutions that I've prepared. I will show my thought process, and I want to be very clear. These are solutions that I've prepared, but that doesn't mean that they're the best solutions. If you found that, if you've come up with solutions that are perhaps more efficient or better code, totally fine. We're in this to learn together. So let's read the exercise first. One of the simplest and most widely known cipher is a Caesar cipher, also known as a shift cipher. In a shift cipher, the meanings of letters are shifted by the same amount. Cool. So what we're doing here is essentially encrypting messages. This is something that was used around 100 BC, if I remember correctly, by Julius Caesar to encrypt his messages and send them so that nobody could figure out what the messages said. So yes, that's what a cipher is. Omran, you beat me to the punch. Yes, what does a cipher mean? It is an encrypted message. It means that if somebody intercepts that message, it can't be read. So you can hide a message in plain sight. And fun fact, this is what a lot of what messaging does today on the internet. They are encrypted, sent, and decrypted by the other side. That's a very, let's say, high-level way of explaining it. But that's what we're going to be doing today. We're receiving messages such as this one here. I'm not going to try and read it in a funny voice. I would love to, but we got to be serious here. So we've got this message. And if we scroll down just a touch, we can see that it should be decoded to the string free code camp. So this string here, we, amongst many others, we need to be able to pass at any string, and it should turn into into the decoded cipher. So a common modern use is the ROT13 cipher, where the values of the letters are shifted by 13 spaces. So that is, A will be encrypted as N, B will be encrypted as O, C will be encrypted as P, and so on and so forth. So we're going to write a function that takes a ROT13 encoded string as input and return the decoded string. So the ROT13 encoded string means that it's already encrypted and we're supposed to decrypt it. All letters will be uppercase. And here's an important requirement: do not transform any non-alphabetic character, i.e. spaces or punctuation, but do pass them on. That means that, for example, spaces will not be decrypted. They will just stay as spaces. We cool so far? So things like full stops, exclamation marks, and that sort of thing will stay as is. We're only going to change letters. And more specifically, we know from the exercise that these will always be capital letters. So we don't need to worry about making them lowercase. Okay, so I'm going to try and come up with a solution in a kind of pseudocode kind of way. I'm going to be what happens with enye, the N with a tilde on top. It will stay this. We're not going to deal with enyes, or do they still do ch in Spanish as a single letter? In any case, we're not going to do that. Cool. All right. So let's get started. So the way I'm going to do it, right? I'm first going to verbalize to you as a team. I'm going to tell you what I think I'm going to do. First, I'm going to take an empty string and I'm going to loop through the message, the str, right? The str string. Remember, that's the encoded string. And for each, I'm just going to loop through each letter and decode it, right? I'm going to look up if that's a letter, and if it is a letter, return the decoded letter into that string. Not return it, sorry. Add it to that string. If it's not an encrypted letter, then I will just pass the same character as is. Let's write some very messy code. Let decoded str equals empty string. Okay? And instead of returning str, I'm going to return the decoded string. And do you know what? I'm going to comment out this function call here, and I'm going to console log ROT13 and the letter A. Now, what? Sunflower Was says, messy code, my specialty. Mine too. Let me have a sip of water. Okay. Cool. We're going to do a more dedicated Q&A at the end, but if anything urgent comes up, please feel free to ask and I'll try my best to answer it. So if I console log ROT13A, nothing is getting printed out because right now I'm returning an empty string. So far, so clear. So let's do a for loop. For, now we're going to loop through the entire string. We're going to let I equals 0. I must be smaller than str.length. And I will go up by 1 character. Now, just to begin, we're going to decode. We're just going to add to it the original characters, not decoded. So they're going to stay encoded just for now. Decoded str plus equals str and the character at position I, at index I, which gives us A, right? So we just loop through the entire string. Let's put in ABC just for good measure. And that'll give us A, B, and C. Okay? So far, so good. What we need to do next, and I'm just going to add some comments here. If the string is a letter, add decoded letter. A string, sorry, character. It's a letter, add decoded letter. So if, right, we'll have an if statement. It'll do nothing yet. Otherwise, or else add character as is. Else, we're going to add the character as is, which means we'll just take this here. Doing that here already. So our code is giving us a whole bunch of errors. Let's see what we got here. It's saying unexpected token. That's because I've got just some brackets here with nothing going on. And that's fine. Let's make sure that we got a good understanding of what we're doing here. So if the character is a letter, add the decoded letter. Then we have to actually decode letter, add decoded letter to string. So we're doing a couple of things here, and I'm just leaving myself some notes just to make it clear for myself. Now, what we could do, for example, knowing that A is N, B is O, and C is P, I could, for example, have an if statement where it says like if now string at position I is equals to A, we could return, sorry, not return, decoded string plus equals B. N. My goodness. We're already getting some progress here. N, B, and C. So far, so good. But of course, it's not always going to be A. It's going to be 26 other letters. So I could add a bunch of else if statements, add up to 26 else if statements for that, which is a bit much work. So we've got a couple of options. We could do a switch statement. That would work. But actually, what I want to do today, knowing that these letters will always be the same, is to have I like what Alejandro says, a character chart. Let's do that for ourselves. Why don't we? So I'll just add this in comments. A will be it corresponds to N, B corresponds to O, C corresponds to NOP, D corresponds to Q, and so on. And Ahmed has the same idea I do. Let's use an object, because you can see we're mapping that relationship between the two. We could use an object so that we can look up that character. Let's do that. So let's use a const and call these, let's call this character chart. Why not? So we're going to have an object here that's going to be a chart of each character. So we'll do the same thing here. A corresponds to the letter N. B corresponds to the letter O. And this is going to take a little bit of manual typing. C corresponds to P. D corresponds to Q. Ahmed says it very quickly. Click on RUT 13 inside the question text. It's got a map. Is that so? Let's open it up. Ooh, sorry, that's a bit large. Let me make it a little bigger. And there we can see how the characters correspond. Yep. Cool. Let me make it just a touch bigger. It's still quite small. I apologize. So A, N, B goes to O, C goes to P, D goes to Q, E goes to R, F goes to S, G goes to T, H goes to U, I to V, and so on and so forth. Let's keep going. So E corresponds to Q, R, F goes to S, G goes to Q, R, S, T. Oh my goodness, this is really, so I'm going to do the alphabet first and and then I'm going to do the corresponding ones after. So H, I, J, J, K, L, N, M, N, O, P, Q, R S T U P W X Y and Z. Now we're just going to keep going with these letters. So H corresponds to U, B, W, X, Y, Z, A, E, my goodness, C, D, E, F, G, H, I, J, K, L, and M. Phew. Okay. So now we've got our character chart with each character mapped out. Just going to delete this comment here. Let's see what folks are saying in the chat. Let's see. Wouldn't it be better to just have an array with the alphabet letters alone and then shift the index by 13? It's totally one way to do it. As I said, this is going to be the way that I do it because I like what I like about objects is that I'm directly looking up as opposed to looping and looking through. Does that make sense? Let's see what else we got. We can put them in two strings and loop over to them to generate the object. This is one way. Bhavin, will this code not be classed as dry? And I'm curious to know why. Because I don't know if I've really repeated myself that much. Each of these lines is different. Again, it's, as I said at the beginning, this is not going to be the best solution. This is going to be a solution that I can unlock my understanding with. I have got another solution as well that I'd love to show you folks. So yeah, we'll go through both. Laura asking a great question. Can we assume all letters will be uppercase? And we can see that here in the exercise. All letters will be uppercase. We could, if we had an example where these wouldn't be, we can do that as well. So yes, Alfonso also asks, what about a lowercase letter? We're not doing lowercase letters, only uppercase. Alejandro says there are some string methods that make this easier and totally fair. Is it possible to allocate a numeric value to each letter of the alphabet, then have some sort of n plus 13 type idea, convert to a number back to the corresponding letter? Hold on to that thought is all I can say. I don't want to spoil. Sunflower asks, do we need a character map for space and or punctuation? No, because the Caesar cipher will, as this exercise describes, will leave these as is. So you're going to see what I mean in just a second. So we've got our character chart. Now this is specific to a 13 rotation Caesar cipher. If it was 14, I would have to redo these, but let's stick to 13 for now. Cool. So if the character is a letter, add the decoded letter. Now we could use a regex for this, as some folks are doing. Let's try that with a regex. So remember, with our regexes, we would say, have our regex symbols. Let's match everything from capital A to capital Z. Remember, we're not worrying about lowercase. So dot test. Then we need that character, which is str at index y. So far, so good. So if it matches, if A to Z matches this one of these characters, now we're just returning n, which turns ABC into n, which is not what we want. So what we can do is say decoded str plus equals, let's just remove this. And now we want to look up that character from the chart. And we can do that by saying, hey, for this letter, for this key, give me this value. Remember, it's an object. So we can use bracket notation, character chart, and then we just look up the character itself, which is stri. Whew. So what are we doing? We're adding to the string the value from the character chart, which corresponds to this character. So now we're getting NOP, which is corresponding to A, B, and C. See, A, B, and C translates to NOP. Now, let's try it with punctuations and spaces. Because this regex is not matching on these letters, we just give it the original character. Let's try logging out this one here. Hey, free code camp. Let's add some more comments for clarity here. Declare empty string, loop through letters in encoded string. If the character is a letter, add decoded letter. So if the character is a letter, which we do here with our regex, we test that this regex matches this character. Remember, it's a single character. Decode letter, add decoded letter to string. So we decode our letter, which we do here, and we add that decoded letter to our final string. If it is not a letter, if it's not a letter, we just add the character as is. So decoded string is plus equals to string at position I. Lunatic Omega asks a question, can we do without else? Not off the top of I can't think of a way to do it off the top of my head, but maybe we could, for example, I don't know actually. If you have a suggestion, please put it in the chat. Let's try other strings here. Yeah. So this string should give us free pizza. I'm liking that. Okay, go for some free pizza. Ah, Richard puts it much better than I. Else takes care of non-alpha characters. Well put. Couldn't have put it better myself. So that gives us free pizza. Very nice. Ah, Druville, you put this very well. Maybe switch can help. Absolutely. We could have let me just scroll up real quick if I may. Instead of having a character lookup chart like we do here, we could have a switch statement. If character is A, then set return N, and so on and so forth. And in the default case, we return the original letter. That's a great point. Thank you. Laura asks, what does test do in regex? What it does, check out, by the way, the recording from the regular expressions as well. You'll find that in the Bootcamp's YouTube channel. What test does is it says here, for this regex, is it matched inside this string? So does this pattern show up in this string? And this string only has one character. So if this one character is a letter, it passes. If it's not a letter, it does not pass. I hope that makes sense. And Replay says, if you run the test, it works. Let's get there. I want to try more. Let's try this one. This one should give us free love. Okay. Free love question mark. Good. Let's try this one. This one should give us the quick brown fox jumps over the lazy dog. The quick brown fox jumps over the lazy dog. Cool. Ah, Ahmed has a suggestion for removing the else. If after the last line, we put in continue. Ah. Ooh, let's try that. Now let's find out why this works. So, forgot my semicolon. How silly of me. So what are we doing here? We've changed the structure just ever so slightly using the continue keyword. And what the continue keyword does is it says, hey, if this gets run, stop what you're doing and jump back to the top of the loop. Start the next iteration. Right? So if we've added this character, then just stop. Just keep going. Go to the next loop, the next iteration of the loop. This is a nice keyword if you want to avoid the else. Thank you very much. Yeah, y'all are so smart. Okay. I'm feeling pretty good about this. Let's run our tests, and if they pass, let's go over it one more time, and then we'll do our second solution. So let's run our test. Fingers crossed. Yep. Pat, pat. We've done the third project, but let's explore another solution. What I hope to do with this is not to give you the solution, as said, but to unlock, sort of show my thinking process and hopefully unlock a better understanding of how to go about it. Maybe you find a solution that's much better than mine. In fact, what I encourage us all to do after this is I will put up a thread. No, I believe there is already a thread in the forum. You will find the forum, by the way, through here, group.glasscentral.com, and I believe some folks are already posting their solutions. So please feel free to do that. Ooh. So what do we got here? To make it work with lowercase characters, we just need to add the regex for A to Z and lowercase A to Z or A to Z with an I. Yes, totally. That's one way to do it, but bear in mind, let's go up real quick. We still need to make this work with lowercase letters because these are currently all uppercase. So one way I would go about it, which wouldn't be all that dry, is to repeat all of these, but for lowercase letters. Again, this is one way to do it. Whoopsie, I unshared my screen. Hi, everybody. That was an accident. Yeah, we're back. Sorry about that. Let's try an alternative solution. The reason I've done this solution, and a lot of you folks were asking me, can't we convert the characters to numbers and that sort of thing? The reason I did it this way was just to do it with the knowledge that we've gathered in the bootcamp so far without looking stuff up. But what if we were to look stuff up? For example, how to turn a character into a number. A number, because if we've got a number from, say, 1 to 26, remember there are 26 letters in the alphabet, we could add and delete 13 that way. And that's totally one way to do it. Jolene makes a good point, and I think Elioskas makes the same one. We could just use 2 uppercase, and that's totally fair. You can totally turn the string into an uppercase string. Can you just make the lowercase input uppercase, then convert it to lowercase for log? Totally one way to do it. Thank you all for the suggestion. And Foso suggests parse int. I'll tell you what. Let me refresh. I've got my code saved this time. Cool. Let's try out parse int. Let's see what it does. Let's take a string called let const string str equals a. And let's console log parse int with that character str. See what it gives us. That gives us not a number. That's because a is not a number. If we were to parse int 1, that would give us the number 1. So we can't quite use this. Let me instead show you something else that we've looked up. I found it on MDN, and some of you folks posted similar solutions, and I want to explore that. I'm going to explore something called character codes. So what we can do is take this A and turn it into a character code. And what you can do is call str.charCode at, and then we'll call it, and then we need to give it a parameter, and that parameter will be the index. The index will always be 0. Look at this. This gives us 65. Let's try with B. 66, 67, 68, 69, 70, 71, H is 72, and so on and so forth. Let's go all the way up to Z. 90. Hey, now we've got something. We know that our characters will lie between the numbers 65 and 90. Something to bear in mind. Let's build a new rotation here. And I want to make this a little bit more flexible. So what if Lunatic Omega asks, is there anything like parse char? And that's exactly what this is. Char code at. Oh, wait, fun fact. What if we wanted to do it the other way around? What if we wanted to turn a number back into a string? For that, we've got another function called from char code and give it the number 65. Let's console log that. Ida beat me to it. Also, string from char code does the reverse. Thank you. You will find both of these functions in MDN. That's how I found them. Let me just put up the link. Mozilla's MDN web docs. You'll totally find this stuff there. So, as Ida said correctly, string from char code does the reverse, and we can see that here. If we do string from char code 65, that'll give us the letter A. Whoopsie, sorry about that. Cool. So let's do that now. First off, let's make this dynamic, just for fun. Let's say that, let's define a rotation, right? By how many characters we will rotate in our cipher. We know that this is going to be a 13. So for now, let's make this constant 13. Okay? First off. Next, let's say we've got it. Let's do like before. Declare empty string. And we'll loop over str. Inside, let me just declare that real quick. So let decoded str is equals to 13. No, not 13. Empty string. My goodness. Oh, yeah, no, you're totally fine. Oh, not str as a parameter. No, you're totally right. Sorry, I didn't see that. It's the character code. Exactly. So you want the 65, for example. My bad. Next, we'll loop over str. Let's do that for let I equals 0. I is smaller than string dot length. Like before, I plus plus. Now, I'm going to define myself a variable here just to hold that character. I'm going to call it char. Str at I. That's going to be my original character. Next, I'm going to define my constant char code. Here I'm going to get that character code using the, what is it? Str char code at, and then the index, which is I. Let's console log that. Char code. Should get, let me just, where am I? Let's remove this console log here. And let's take a look. So for SERR, PBQR, PNZC, we got 83, 69, 82, 82, 32, 80, 66, 81, and so on and so forth. Look at all these characters. So these are the character codes for each character that's in the encrypted string. So far, so good. Folks, you got to stop me in the chat if I'm saying anything that doesn't make sense, please. Next, if char is a letter, decode string, like before, decode char. Otherwise, add char. Let's do the else first, since we already know how to do it. That would be decoded str plus equals char. Cool, we've done that before. And the if is going to be pretty similar because we already know how to check if something is a letter. We'll do our regex. We'll do our regex here, matching anything between A and Z. Remember, they're all capitalized. Dot test, and we'll pass in char. Remember that character is a string. Let's stop console logging those character codes for now. Whew. So if A to Z matches the char, then we need to decode that string. Now, what we can do, now that we've got that character code, we can add or subtract 13. Now, why add or subtract? Remember how the Caesar cipher goes. It needs to move 13 characters. But here's the thing. The alphabet has 26 letters. So we're going to have, right, sorry. My mind kind of went blank for a second. So we're going to have, for example, A turns to N. That's A turns to N. That's 13 letters over. But N also turns into A, remember? Let's take a look at this here. Let me make it just a touch bigger. Because that rotation goes both ways. See, A maps to N, and N also maps to A. So we can either add or subtract 13. That's a nice little bonus to have. Lunatic, I will explain regex shortly in just a moment. I will finish this solution and then we'll get to the regexes. I hope that's okay. So let's do that. And what I like to do is to have an if statement inside our if statement. And I will say if char code, remember that's a number, minus rotation. Remember our rotation is 13, is bigger than or equals to 65. That is, it's a letter that's M, N, or beyond. Then we will add to our decoded string. First, before I add to our decoded string, let's decode the character. So const decoded char equals to char code will be char code minus rotation. I'm just doing this as a proof of concept first. We'll clean it up in post because I see here a suggestion that I really would like to try, but one thing at a time. So, yeah, and we will add to our decoded string. Remember what we did before? String from char code. We can get decoded char code. Getting there. We're not all the way there yet because we want to have an else statement, meaning that we can add 13 to our decoded string. So const decoded char code is equals to char code plus rotation. Then, like before, we can add to our decoded string. String from char code, decoded char code. Whew. I don't like this. This looks messy. Let's clean it up in just a bit. Let's first test that it works. Let's console log our result. Console log undefined. I made a mistake. That's why it doesn't look like. Shika asks, could you please explain line 13? Yes. Yeah, totally. What I'm doing is taking our character code. Remember, our character code is a number that represents our letter, right? And remember that the Caesar Cipher, what it does is it moves over that character 13 letters. So what we want to do is add to that character the 13 letters. So we're adding 13, or at least the amount of our rotation. Oh, sorry, line 11. Oh, I'm sorry. Line 11. Okay, gotcha. Let me finish explaining line 13. We're adding 13 to that letter so that when we convert it back into a string, it'll be a string, a character that's 13 letters bigger. But yes, let's look at this one here. Okay, yes, our regex. So we've got a regular expression here that says, hey, match this string if this string matches the pattern of having any character between capital A and capital Z. So we're saying test this regex to see if this character is any character between A and Z. Meaning we're checking if it's a letter. So let me see what I did wrong here. If char code minus rotation is bigger than or equals to 65, we declare our decoded char code to be char code minus rotation, and string from char code, decoded char code. Why am I getting undefined? My goodness. you think I made a mistake in my outer else statement. It is entirely possible. Decoded str plus equals char. That actually looks okay. Let's take a moment to clean this up a little bit. I want to try and clean up using Alejandro's suggestion because it looks really cool. A to M and N to Z. Let's try something else. So instead of matching, I'm just going to delete my code here and start over a little bit because I think I got everything completely wrong. If if the pattern matches anywhere between A and M, we know we can add 13. So let's do that. So const decoded char is equals to char code plus rotation. Let's console log that. Decoded char. Actually, let's do char code and decoded char. So for each character here that matches, we're saying 69 plus 13 is 82, 66 plus 13 is 79, 67 plus 13 is 80. So that looks good. Next, let's decoded string should be plus equals string from char code decoded char. Let's console log decoded str now. So sr srrrpo. See what we got. So let decoded str is equals to this. We'll loop through the entire string. We will have a char that's that character, and we'll have a char code for that character. So far, so good. If it matches anywhere between A and M, we declare the decoded char to be that plus rotation. Let's else if, and here we're going to do the other side of that regex. So inside here, we're going to try N to Z matches the character. We're going to do the exact same thing, except by moving the character back 13 spaces. So let's do that. You know what I'm going to do? I'm going to copy this code because it's almost identical. Const decoded char is equals to char code minus rotation. Decoded string is plus equals to string from char code decoded char. Ahmed, you were right. Yes, that's what I'm missing. I'm missing to return decoded string. Thank you. How silly of me. So, if the character matches anywhere, let me just switch real quick to here. If the character matches anywhere from here to here, then we'll add 13 letters to it. Right? Otherwise, if the character matches anywhere from here to here, we'll subtract 13 letters. That way we don't have to deal with, for example, what Omran suggested here, which is to use the remainder operator. I'm not saying this is bad, huh? This is really good. What I like about using regexes is that it's clear to me where we're matching based on what. Again, personal preference, and totally up to you. In fact, could I copy your code? Let's give that a try. First off, let's see if this passes the tests. Fingers crossed. So, A to M. Sorry, Mati, you said you can't see it. Could you elaborate on what you mean? You mean the solution? I've got it right here. I hope everybody can see it. I don't know if my video froze. You can't see my map. Oh, you can't see my map. Oh my goodness. I'm sorry. Do you know what? Let me just reshare. Hi again. I was sharing the tab and not the window. Computers, and I'm so silly. Let's yes. So if we match anywhere between A to M, we add those 13 letters. You see? If we match anywhere from N to Z, we subtract those 13 letters. So that's totally one way to do it. Thank you very much. I completely misunderstood what you meant. Cool. Yeah, so we've got A to M, we add, N to Z, we subtract. So far, so good. Let's try what Omran suggests. Ooh, this looks fancy. I like it. So if we match, oh, sorry, no. First things first, let's make sure that this works. Run our tests. Fingers crossed. Yep, that's a solution. Pat, pat. Now, let's do another one. Let's try decoded as, let's try this here. This looks fancy. I like it. So if we're going to match any letter, we're going to remove this if else. And now let's see what we've got here. Omran, could you also type in the chat why, could you explain the solution in the chat? I'll also try and figure it out, but I'd love some help. So decoded char will be equals to 65 plus char code minus 65 plus 13 remainder character 90 minus 65. I think I copied it right. So 65 plus char code minus 65 plus 13 remainder character 90 to 65. Yeah. And this seems to give us, this should print out free code camp, but it's giving us something else. So I wonder what's going on here. Let's take a look. We're having 65 plus, let me just add these together if I may. Char code minus 65 plus 13, remainder operator 90 minus 65, which is 26. No, 90 minus 25 is 25. So we could call this 25. Let's simplify this maths a little bit. Okay. Char code minus 65 plus 13 is 78. Oh, look at that. Okay. So 8D, 5D, Cam 6. We're getting there. We're getting there. Interesting. I do want to hear why this works. So please, if you can explain to me the solution, I would love it. I mean, I'll do it. I'll try my best and decode it once we get it working. I believe this should be 26 because we've got 26. No, I guess not. Odd. 35, not. Oh, am I bad at math? 90 minus 65 is 35. My mistake. Not quite there. Char code minus 78. What was it again? 65 plus 13 is 78. So where's the 78 coming from? Why are we getting a different solution? I'm just going to try. Well, no. So char code minus 78. What if we did this? No, not at all. Not at all. Outer brackets. Could you elaborate, Richard, please? I love that this turned into like an ensemble programming experiment. I love it. So, 64? It doesn't seem to work either. And y'all are giving me lots of math here, and I'm not really sure how to make this work. So we've got 65 plus 65 outside the brackets. Okay, Ravi says 65 outside the brackets. Good, got it. So then we've got, could you explain 90 minus 65 is equals to 25? Yeah, that's what I thought. Oh, around the 35. Okay. So, okay, like this. Or brackets around the 25. That shouldn't change much. Let's take a look. So 65 plus char code minus 78. If I were to Aha. Carlo98 says char code minus 78, remainder 65. Okay, let's do that. So char code with a capital C, minus 78, remainder 65. That doesn't seem to do it either, does it? It seems to be giving us, I mean, let's console log decoded char. This is giving us, no, this is giving us letters that are well below. We need our char code to be between 65 and 90. So what if we were to make this 65? This looks better. So I think I see what's going on here. What if we were to add 65 to this? See what we get. Okay. This still gives us free, like that seems like R, O, and P, and they are all beyond M. So it's the latter half that's not working. This one here, this is not working here. Well, this is tricky. Let's have a look. What if minus 52? Yep. Muslichin says, I think it only works for A to M, and you're absolutely right. So we would need to have our second solution anyway, our A to M match and then our N to M match. So I'm afraid that's not quite it. As Ricky correctly says, we are adding 13, but not subtracting, seems like. You're absolutely right. So I'm afraid we'll need to, I'm just going to go back to the solution that I had before, if I may, if nobody minds. Let's go back to having our solution from before so as to not get too lost. Oh, remainder 26, huh? Let's give that a try. Thank you. It still seems to be giving us free code camp. Now, why would that be? Let's print out this number. Console log char code, and then decoded char. So we're at our original char code, we're subtracting 13. We're doing that correctly. Cool, so on and so forth. The problem is that some of these are landing below 65. So this isn't quite what we want. Now, the reason for that is because this is 65 plus 13, which is 78. Should give us the same result. Yep, I agree, Ricky. We need plus 78. Let's give it a try. Okay. Let's put this the way it was. So 78. If that matches A to M. Oh, it's subtracting, so we should be adding 13, which is 65 minus 13 is 52. Right. Gosh, doing all this math is really confusing me. Let's try copy pasting this. Else if is N to Z. And here we do 78. There we go. So if we do A to M, we do the test. Is there a link to the problem? Yes, I put it in the chat before. I'll put it again. Here it is in the chat. Laura correctly says, we're only checking if it's a letter, not if it's A to M or N to Z. Ooh, Ida's got a solution. This also works. Plus 65. Remainder 26 plus 65. And that would work in both cases? So let's give it a try. Minus 13 plus 65. And here would be char code plus, sorry, minus 13, no, plus 13, sorry, plus 65. Free code camp. Yeah, because we're still rotating that character by 13 spaces. But I don't know, this seems much more complicated than the way we were doing that before, which was just char code plus 13. No, I am wrong. Minus 13, my apologies. Yes, and here, char code plus 13. We didn't really need the remainder operator there, because if it's A to M, we want to add 13 characters, and if it's N to Z, we want to remove 13 characters. Phew. Okay, so this looks okay. Let's run our tests again. Yes, pat. Cool. Awesome. Well, let's take a step back. We've been at this for almost an hour. Congratulations to us. So there's two solutions that I made, and I said they don't have to be. Carlo very correctly says, "Oh, you mean the percent sign is not that readable?" I mean, what I want to be very clear on is that this is code that's good to be readable for us, right? So if it makes sense to us, that's already a step forward. If we can get some feedback, like you have all very kindly done to me and given me the feedback, you can totally do it that way. Don't apologize for your question, Omran. This is what we're doing. We're learning. Ooh, Avi has something here. I see a lot of hard-coded elements in the code. I would rather have it dynamically done with arguments passed. I'm with you. What if we wanted to, and actually we can do this because we've got our rotation here. We can, instead of 13, have rotation. That way, if we wanted to have any kind of rotation, well, all we got to do is change it up here. But that's still not quite nice because we still have hard-coded how many elements. So one thing we could do, for example, is have two regular expressions I see here, regex1 and regex2. So this is just for fun here what we're doing. This has nothing to do with the project anymore. Here we're just cleaning stuff up. Leon very correctly says this is using things we've learned so far, not things that may come ahead. Absolutely. We can only use the tools we have. And Elioskas, y'all are so much cleverer than I am. Let's make rotation a parameter. Totally. So let's change this from rot. Let's rename this to be a little bit more accurate. Let's call this decode cipher. Cool. Now, of course, rot 13 is not rot 13 is not defined because we just renamed the string. And let's pass in 3 more parameters. One will be rotation. The other one will be, let's call it lower half regex, lower alphabet. Let's call it lower alphabet. And then the second parameter will be, the fourth parameter, pardon me, will be higher alphabet. Cool. So let's do the rotation first because this is not being used. So rotation and rotation here. Now, lower alphabet, let's use, instead of this regex here, let's use lower alphabet. And here we'll use higher alphabet. Almost there. Now we need to change our declaration here. So let's call this decode cipher. And instead of doing this, let's first pass in our rotation, which is rotation in all caps. Then we'll pass in our lower half regex, which is A to Z. No, not A to Z, pardon me, A to M, and our second higher alphabet regex, which is A to N to M, Z. My goodness. Okay, now this decodes to free code camp, which is pretty cool if you ask me. But what if now we can change it around? Let's make our rotation, I don't know, 1. And the lower alphabet will be A to B. No, A to Y. No, A to X. Higher alphabet will be Y to Z. Actually, I think it'll just be Y. Let's make this rotation 2 characters. So ABC should translate to CDE. I think I did this completely wrong, everybody. I'm just messing around here. Oh, let me just answer this question real quick. If you submit your code, pass the test, and forget to download it, can it be retrieved later? I mean, does the application hold your coding history? Yeah, I think it does. As Leanne correctly said, it resets once you move ahead. This has happened to me live, so I hope you didn't lose your code, Dimitrios. I think if you do like Shift S, something, Control S, there's some key combo that allows you to save your code. I don't know where I saw it, but I stumbled upon it. Maybe it's no, I'm not gonna mess with Alt S. Nope, that gives me a German S. Never mind. There is a key combination. I'll see if I can look that up. Ah, Bavin says you can find your code under the settings. There you go. Here, Ramon, so you don't have to count. Thank you. Let's try out this link. computerscience.co.uk/site/Caesar Cipher. Much appreciated. Let's have a look at this link here. Ooh, this is fun. Oh, sorry. Yeah, I'm doing it on my other screen just to make sure we've got something good here. What am I doing here? So if we encode, let's encode ABC. It decodes to CDE, which it crypts to CDE. That's my mistake. So this is actually encoding. If we wanted to decode, we would have to do it the other way around. Because with the rotation 13, it didn't matter which way we decoded. Now it does matter. Yes, Matty, I'm very sorry. I purposefully didn't show it, but like if you want to play around with Caesar ciphers, Elioskas has got you covered. So I very purposefully changed this the way around. So if we want to decode it, we want to match this the other way around, don't we? So Y to Z and A to X. Does that look good? No, it doesn't. I'm just confusing myself. I'm sorry, folks. It's a lot of the times like this. If we wanted to decode something by 2 spaces, for the lower alphabet, we would want to subtract. No, we wanted to add 2 to decode it. That's our problem. Decode it. If our lower alphabet matches, we want to go up by 2. And if it doesn't, we want to go down by 2. That's my problem. Ah, how silly of me. Try this. Here we would need the, here we would need the remainder character. Do you know what, folks? I'm going around in circles and I don't want to waste anybody's time anymore. How about we cut our losses with this and we go straight into Q&A so that I can respect y'all's time. Thank you for going on this silly journey with me. And if you're with me so far, congratulations. And ooh, Sergey's got a suggestion here. I cannot type all of that at once. I will take your word for it that it works. Put this solution up on the forums and the Discord, please. Let me just enroll in the bootcamp here. If you do this here, group.classcentral.com, you can go ahead and post your solutions there. There should already be a forum for you. Thank you, Sergey. Cool. So, yeah, let's do some Q&A. Let me bring up one of my other solutions. I'm going to bring up the one that I did a while ago with the object, because I like that one. It just makes me happy. Give me 1 second to bring it up. In the meantime, congratulations on doing your third project. If you've already done it, wonderful. Pat, pat. Yeah. Oh, we got a question maybe? Just bring up my old solution here with all of my messy characters. Oopsie. Just cleaning it up a little bit because it looks like a bit of a mess. Character chart. Character chart. Yeah. I'll just bring up my old code here. And this one I did it a little bit differently, huh? For example, I had my character chart here with the letters like before, but instead of checking if the regex matched, there's a total way to do it. For example, checking if the character has its own property. And I love what ZolaTube said here. Learned to think of many options for a problem. Absolutely. There's totally many options to weigh, and the tools of programming allow us to be able to come up with those different options. And as you saw me do today, you can get totally lost in coming up with something that doesn't work all that well. Yeah. So do you know what? There was a question before. Let me go back to that real quick. Somebody was asking if I could please explain regex. Regex. Laura, yes. What does the test do? Let me explain the regex again. Just to go off on a little bit of a tangent here. Let's just add some more code. It was lunatic. Sorry. Please explain regex in short. So we've got regexes are const. Let's call this my regex. It's a pattern of characters matched inside these forward slashes. So, for example, a type of regex is a, or dot, meaning any character. Let's go with a for now. So what we can do is my console log. Let's console log what happens when we want to match a regex. My regex.test, a string with har. Cat. Yes. Now, what the regex does is it says, okay, in this string, is the pattern a letter A present? Anywhere in the string, is there a letter A? And it matches. Good. Does at, whoopsie, I opened a new tab. Does at match? Yes, because AT is there. But what about, I don't know, at match? False. Why? Because this is cat. CAT does not match BAT. There are other ways of doing it. For example, you can have it match any character. So any character followed by A and T works with cat, works with bat, works with hat, works with pat. Of course, pat. How could I forget? Yeah, I said we covered regexes last Monday, and the video recording is up on YouTube. So I would recommend go back, check it out. You will find everything in classcentral.com, and the YouTube channel will be there as well. So we got some comments. Okay, cool. Regex. We're going to do some regex challenges. Reuse patterns using captured groups. Can I explain it? Yes, totally. I also did this one in one of the Q&As, but let's do it again. I'm going to go back to Free Code Camp, go to my JavaScript algorithms and data structures. Regular expressions. Yes, and it's reuse patterns using capture groups. Yes, I remember this one. Reuse patterns using capture groups. Yes, totally. So speaking of regexes, we've got here 42, 42, 42. We've got the regex change, and we've got result equals regex test repeat num. So let's console log that result. Console log result. Whoopsie. That gives us false. Why? Because 4242 does not contain the characters change. Makes sense so far. But what is it? What we can do is match, for example, let's say we wanted to match 42, 40, any series of 3 numbers. We could do digit plus space digit plus space digit plus. This covers, hey, 1 or more numbers followed by a space, whoopsie, followed by a space, followed by 1 or more numbers, space, 1 or more numbers. What we can do beyond that is if we want to match the exact same pattern, is we can surround the first part with brackets. Now this is matched in a group. Notice it didn't affect it anything. So the brackets are being ignored. It's just saying, hey, capture this pattern, please. Yeah. Then we want to reuse, if we ever want to reuse that pattern, we can just go, hey, backslash any number of digits. And then the number 1 denotes, hey, match the first group that I captured. So group, group again. Yeah. Yeah. So our exercise here is to use capture groups in regex to match the string that consists of only the same number, the 42, 42, 42, repeated exactly 3 times separated by single spaces. And this looks good. This group matched twice. Let's run the tests. And it's failing because, Free Code Camp helps us and says, your regex should not match the string 42, 42, 42, 42 because it's being matched twice. This pattern actually shows up twice in this string. It shows up like this, all good, but it also shows up like this. So this won't do. What we need to do is make sure that the string begins and ends with this pattern. And we can do that with the caret, which tells us, hey, the string should start with this, and the $sign at the end that says, hey, the string should end with this. So the string should end with a series of characters, a series of digits, which are captured in a group, matched twice more exactly, and then end. Run the tests, and there we go. Pat, pat. A asks, is dot in JS same as star in other programming languages like Java? I want to be very careful with the dot. The dot is not in JS. It's in the regular expressions that are in JS. And in regular expressions, dot always means dot, wildcard, so any character. Yeah, we can totally do that. Hope that helps. So the star, which in regex means 0 or more, would be the same across different programming languages that use regex in the context of regex. I hope that makes sense. So Elios asks, since we're here, could you do the last exercise we had for homework? I'm just curious how you'd go about it. Sure. That's what we're here for. Let me scroll down real quick. Sorry to scroll back so much. I know it's a little bit. Yes. The homework between yesterday and today was to do the last exercise of basic data structures. I'm just going to redo it. Well, do it because I haven't done it here. I didn't do my homework. So what is it? What we've got here? We've got an object called user, which has three properties: name, age, and data. And inside data is another object, which has 5 properties: username, join date, organization, friends, and location. Cool. And I see that this is a string, this is a string, this is a string, and this is an array of strings. And this is an object which has itself three more properties. So this is kind of like Inception, isn't it? What is it? 1, 2, 3 levels down. So what's our exercise? We've got a function here called add friend, user object friend. And take a look at the object we've provided in the code editor, which we've done. The user object contains 3 keys. The data key contains 5 keys, one of which contains an array of friends, which we see here. From this, you can see how flexible objects are as data structures. We've started writing a function called add friend. Finish writing it so that it takes a user object, which it does here, and adds the name of the friend argument to the array stored in user data friends and returns that array. Cool. So, whoops. Where did my window go? Sorry. So we got add friend. Now we want to user.data.friends.push. Oh, sorry, it's not user, it's user object. Yeah, .data, right? .data.friends, and then we want to push the friend to the array stored in data friends, and it returns that array. Return user object data friends. So we originally had Sam, Kira, and Tomo, and after calling this, we return Sam, Kira, Tomo, and Pete. As Dreamy Player correctly says, data friends push friend, and then return user object data friends. Cool. Omran says, this is in relation to the previous exercise we did. Thank you. You think we can use look ahead and look backwards? I think you can. Give it a try. I'll answer some other questions in the meantime. But I think you could, yeah. Ida asks, would using a class be unnecessary for Caesar Cipher? Implementing a class that both encrypts and decrypts a given message with any given rotation sounds like a nice idea for a side project. Ida, that's wonderful. Yes, absolutely. You could do that. So you could have a class. I'll just write this in pseudocode. Okay. Like super messy code. Let me delete everything in here. So we'd have a class, called, let's call it Caesar Cipher, that has a constructor that takes, I would say take a rotation, new rotation, as I like to call it. In the class, we'll store the rotation, new rotation. And then we would have 2 methods on it. One would be encrypt string. I'm not going to implement it, so I'm just going to leave it there. And decrypt string. This is lovely. This would make a wonderful side project. If you do that, please share it with the group. I would love to see that. John asks, which stream had the regex problems? If you go back to the YouTube, if you go back to the Class Central Bootcamp, you will find all of the solution, all of the previous streams there, including the YouTube one. It's called Let's Learn Regex, or Let's Learn Regular Expressions. Let me bring up the YouTube channel, see if I can find it. Do you know what? I'll post the link here as well. Give me 1 second. Class Central, just doing it in the other window. You've done it. Thank you. Thank you very much to my assistant. There you go. Just going to display it here. Yeah. Okay. Phew. I'd say congratulations on being done with week 4 of the bootcamp. Tomorrow we've got a guest session from Parham. We're going to do Everyone Matters, an inclusive approach to design, development, and testing. Also, on Monday, we're going to come back and do JavaScript algorithms. We're going to start with, let me scroll down here, basic algorithm scripting. No, am I doing this right? Yes. Basic algorithm scripting. Then the next day we'll do object-oriented programming. I'm excited. We're going to learn all about prototypes. Then we're going to do the telephone number validator project. Also, on Monday, right after the lesson, we're going to have a bonus guest session, which I'm particularly excited about. That guest session is going to be from Mr. Stuart Langridge, who's going to tell us about why we sometimes might not need frameworks and why we sometimes might not need JavaScript at all on our websites. I highly recommend stopping by. I don't know if there's, I believe the event will be up on Class Central, and then if not, it'll be up shortly. But I'm very excited. I'm very thankful to Mr. Langridge for joining us. Let's do one more question. About regex, how do I pass the matched pattern to a group of words? Not sure I understand the question, I'm afraid. Let me Caesar Cipher. Let me just delete this code. Let's say we have const str equals hello world. And we'll do const my regex equals low. Not the most elegant regex in the world. So if we want to get let's do let result equals my str.match my regex. Let's console log result. So what we get here is our first match here. What we can do is extract that. Since it's an array, we can just extract that using the zeroth index and get our match. I hope that's what you were asking. I hope I understood. Yeah. Yes, we got it here. Johanna says, if you only add 13, it does it per Asif Dawood solution. Perfect. Thank you very much for sharing, Johannes. Cool. I say we call it a day. I will see you all tomorrow for our guest session. Homework is going to be, as always, if you have time, look a little bit ahead. We're going to start with the algorithm. Sorry, let me just look that up again. On Monday, we're going to do debugging basic data structures, algorithm scripting. If you can, if it benefits you, look a little bit ahead so that you can come the next time with loads of questions for me and we can try and solve them together. After that, stick around on Monday for the guest session, and I'll see you tomorrow for our other guest session. So, folks, it's been wonderful as always. Congratulations on going through the 4th week of the bootcamp, and I will see you tomorrow or next time. Take everybody and have the greatest day. See you later.